Hello everyone, my name is Maja and I'm a student from Polish Air Force University. During 2022 summer internship, I've been working under the supervision of Professor Artur Dubrovsky, Kyle Miller and Robert Edman under the project titled Benchmarking of the Artificial Intelligence-Driven Predictive Maintenance. Let me introduce you my project first. So, to begin with, let's present what is the biggest challenge that the predictive maintenance is constantly struggling with. So, this is the access to the datasets. Nowadays, there's not enough good data which could be broadly available for benchmarking AI-driven predictive maintenance field. Most such data is simply very sensitive, which makes the data very difficult and often impossible to obtain. And also, the researchers need to benchmark the new algorithms and allow for independent evaluation, what may be very difficult when they do not have access to enough amount of data. So, here are my main tasks were to create a repository on GitHub that will gather a large collection of different benchmark datasets. Also, the task connected with the repository was doing the research and assemble relevant literature about applications of predictive maintenance in various fields of technology, with the biggest emphasis on the field of aerospace. And every dataset which I found on the internet, I described and then put to the created for that purpose GitHub repository. And the final task was to summarize findings by writing summaries of chosen articles related to the project and gather them in the research paper in order to give a constructive feedback about the predictive maintenance. And the slides present you what the repository looks like now. So we are given here with dozen different datasets. The actual size of the repository is 26 datasets from different fields of study. For every dataset found here, I wrote a description and provided different sources, citation, and references related to the subject. And this is the sample dataset from the repository. And the dataset itself consists of two subfolders, the dataset subfolder and the documentation subfolder, and also there's contained a README file. And the dataset subfolder contains data needed for the research and analysis purposes, and the documentation subfolder consists of the sources file, where I added links and provided the citation and the references to articles, codes, and to original website from which the dataset has been downloaded. And also there's a README file, where I describe what the dataset is about and what is inside this dataset in order to provide the essential information about the data. Now let's move to another part, that is a newly received dataset. This dataset concerns fighter aircraft where the data has been collected from the aircraft sensors during the flight. So the dataset itself consists of some different files. Each of these datasets is further divided into 5 subgroups data: the vibration, engine, pilot, pressure, and autonomous steering machine. Each of these subgroups contains values that come from sensor readings from the aircrafts. And there is presented this datasets in the slide, and it is divided and marked with different colors depending on their impact and importance to the aircraft flight. And also in the upper part, the first row above the column titles contains different threshold values information about the maximum allowable value that can be reached during the flight. And different colors of the columns provide the information what values the particular columns contains and what impact may have the sensor if its values exceeds the threshold value. And the colors and sensors are also described in the file. So what are the future plans? In particular, I would like to focus most on trying to work on the squared database from the fighter aircraft and, if possible, try to create some predictive maintenance model that, for example, based on the vibration, temperature values read from the sensors and based on determination of the threshold value point and the critical point, could be able to predict the remaining useful time before a failure occurs. And that would protect the aircraft from exceeding the threshold value, which could result in, for example, unforeseen repairs and associated higher costs. And at the end, definitely worth adding is my experience and impressions of the summer internship. So throughout the whole internship, I was able to expand my knowledge to new horizons, fields of science I have not dealt with before. And first of all, I have significantly expanded my knowledge of predictive maintenance. I get to know what are the techniques, algorithms, models commonly used in order to develop well-working predictive maintenance model. I was also able to learn a lot about machine learning, and not only from online sources, books, articles, but especially from the well-organized weekly lectures on machine learning, which were conducted in an extremely interesting and fascinating way, which made listening with pleasure and curiosity. And I could also learn how to search in order to find different sources related to the predictive maintenance field, and also how to collect data from the internet sources and how to describe them. And besides, I could learn how to use GitHub website and how to create a repository in order to make it a very useful tool for other researchers, and that was a very important part of my project. And moreover, I could get to know how to deliver, create, and present presentations, what nowadays is a very useful tool, and not only will this be useful to me at the university, but may also be very useful in a future potential job. And last but not least, I had a great opportunity to talk, socialize with people all over the world. So well, that's all from me. Thank you so much.